This week, we have discussed the matrix factorizations. So specifically, this is the user rating matrix. So we want to decompose this user rating matrix into the user embedding matrix and item embedding matrix. So we are getting this example is actually coming from developers.google.com. And while this simple tutorial doesn't illustrate how these values are coming into, so let's looking into this, let's do some reverse engineering from here to understand, to make sense of these values. So these values are not randomly thrown in. So to start with, as a provider of the content provider, such as in these cases, Google, for example, YouTube. So YouTube have a good idea about the nature of these movies. So in these cases, there are movies here, Harry Potter, Triplets of Bellevue, Shrek, Dark Knight Rises, and Mementos. And it appeared to be the Harry Potter, Dark Knight Rises, and the Shrek are similar. And Memento is an action movie is very different from Harry Potter and those similar to Harry Potter. Triplets of Bellevue is actually similar to Shrek because both are animated movies. So understand this, then we can draw the 2D space. So this is a 2D, 2 dimensions and 2 dimensions. So assuming our user embedding matrix, essentially the U, and the item embedded matrix, the V, is actually a 2D matrix. So now let's looking into the 2D space. And here the black dots is we're talking about is reference each of these movies in the space. So the idea is the movies that are similar to should be relatively close to each other. And the movie says very different from should be far away. So in these cases, we have the Harry Potter, in these cases, and dot 9, 0.9 on the x-axis, and the negative dot 2 is on the y-axis. So supposed to be, that's the first movie. So therefore, I mark this 1 here. And then this is the coordinate of the dot 9 and the y-axis negative dot 2. The next movie, Triplets of the Bellevue, and the Triplets of the Bellevue is the movie number 2. So the movie Triplets of Bellevue is different from Harry Potter's. So in these cases, it was situated in the coordinate negative 1 and negative dot 8. So this is the negative on the x-axis is negative 1 and the y-axis is negative dot 8 approximately. And movie number 3 is Shrek. So Shrek is actually considered similar to Harry Potter. So in these cases, should not be far away from Harry Potter. So in these cases, it will be the x-axis is 1 and the y-axis is negative 1. So that means that this is the movie number 3. So x-axis is 1, y-axis is negative 1. And the movie number 4 is The Dark Knight Rises, and also that is supposed to be similar to the Harry Potter and also Shrek. So the number 4 should be not far away from the Harry Potter. So Dark Knight Rises and the Harry Potter are relatively close. And number 5 is Memento. So it's an action movie that's different from the Harry Potter and the Triplets of the Bellevue. So apparently its locations is the x-axis is negative 9 and the y-axis is 1. So this is movie number 5. So here we have a movie number 1, movie number 2, movie number 3, 4, and 5. So now let's look into the user. So therefore, let's look into what the user is situated. So the user 1 has watched Harry Potter has watched Shrek, has watched Dark Knight Rise. So the user number 1 should not be far away from the movie number 1, movie number 3, and movie number 4. So the user number looks like the 1, the x-axis is 1, y-axis is positive dot 1. So therefore, this red dot, the red value is the user. So it looks like the user 1 is on the 1 on the x-axis and the dot 0.1 on the y-axis. So in these cases, user number 1 is quite close to movie number 1, which is the Harry Potter, quite close to the movie number 3, and also movie number 4. So now the user number 2. User number 2 is actually has watched the triplets of the Bellevue and also the Memento. So user number 2 in this cases is situated in the x-axis is -1 and on the y-axis is 0. So the user number 2 is on the -1 on the x and 0 on the y. So looks like the user number 2 is actually in the between the movie the triplets of the Bellevue, which is number 2 movie, and also the Memento is number 5 movie. And same thing here, user number 3. So user number 3 has watched Harry Potter, triplets of Bellevue, Shrek, and also these 3 movies. So user number 3 has watched Harry Potter, triplets Bellevue, and the Shrek. So user number 3 in theory should be quite not too far away from the movie number 1 and the movie number 2 and the movie number 3. And looks like it is indeed has an equal distance to movie number 1, movie number 2, and movie number 3. And user number 4. User number 4 has watched Dark Knight Rise and the Memento. So user number 4 should be quite close to the movie number 4 and the movie number 5. It looks like the user number 4 is right here. So this is explain these codings, why are these values. So you don't have precisely to be this coding, but idea is the user who watched the movie should close to where the movie is located on the 2D space. We just explained the user embedding matrix, the capital U, and either embedding matrix, the capital V, on a high level. And this is the capital U, the user embedding matrix, and this is capital V, the item embedding matrix. And this is the feedback matrix. And the dot product between the user, for each vector, you can generate a matrix, which is supposed to be similar to this feedback matrix. In the real use, you shouldn't create the capital U, the user embedding matrix, and the capital V, the item embedding matrix, by hand. So there are methods you can invoke to compute the user embedding matrix and the item embedding matrix. So to start with, we need to encode this feedback matrix. So this is actually not the user rating matrix. So typically these are not coming from the rating given by the user. So in the YouTube scenario or Netflix scenario, this simply means that user has watched the Harry Potter, has watched the Shrek, has watched the Dark Knight Rise. It doesn't indicating the user gave the feedback or the rating for these movies. So basically this feedback matrix essentially is a binary. So essentially we can replace this check mark by 1, and if there's no check mark, it should be 0. And once we have this basic feedback matrix, we can actually decompose this feedback matrix into the component matrix, which is the capital U and the capital V. For the matrix the factorizations or the decompose the feedback matrix, into the user factor matrix and the item factor matrix, the capital U and the capital V, and can be through the single value decompositions. And this is just a Wikipedia site about the single value decompositions. And here is the examples. And you have the original matrix, for example, M, in our cases, the feedback matrix, or the user rating matrix. And we can execute or compute the SVD, the single value decompositions. It can decompose this original matrix into the U matrix and the V matrix, and along with the sigma matrix, which is a diagonal matrix. So Apache Spark and offers also, just like many other, the library offer the SVD, the single value decomposition, the method. And Apache Spark also offers that method. And here is the after you construct the matrix, and in the Spark, the matrix, in the Spark, the matrix object, it has the compute SVD. So the result of the compute SVD, you can assign to the SVD, and the SVD.U, you get the user, in our cases, the user factor matrix, and the V, the item factor matrix, along with the sigma, which is a diagonal matrix. So essentially, the U, we can basically use the U as the user embedding matrix, and the V as the item embedding matrix. And from that point forward, and we can using the compute the cosine similarity, and to find the similar users, and in order to create a value for the latent values for the users in terms to the movies. And additionally, and also we can generate the U and the V, and through the alternating the least square, which is our example we have demonstrated in the class.